Hello, students at Veritas. Hope you're doing well. What I want to do now is I want to talk to you about our plan for calculus and physics. You guys are in a very interesting situation because you're actually learning the math and the physics at the same time, like Isaac Newton would have learned. Because when Isaac Newton, well, not would have learned, but would have demonstrated, I should say, because when Newton discovered, quote unquote, when he invented the calculus around the same time as Gottfried Leibniz, who is the co-inventor, he was doing calculus to understand certain things in physics, like the motion of the planets, right? So what you guys are doing is you're doing calculus and physics at the same time. And at the beginning of the year, we've gone at a very slow pace, and that's partly my fault, and I apologize. And I haven't given you as much instruction and direction. So what I want to do now is give you a guideline for our semester and what lies ahead. So let's go back now to, I'm going to share my screen, and I want to show you the physics textbook. And of course, the calculus book, you're working through chapter 20 all the way to the end of that book, right? My goal for you would be to do a lesson a day from that math book. And if you do a lesson and you still have 30 minutes of your 1 hour commitment, quote unquote, then I would encourage you to do another lesson, right? So we're going to learn certain concepts as a class on Tuesday, but I want to encourage you to make sure that you are working ahead if you understand what concept you're working on. So let's look at the physics side for now, and then I'll probably make a different one for math. I believe you're doing imaginary numbers, complex numbers. You're going to start doing more calculus topics, like differentiation. So every day, dedicate 1 hour of time to math practice and 1 hour to physics practice. And then when you do the practice problem, I want you to actually upload that into the section on Schoology that is dedicated to that section. So for example, you do 19.5, upload your work for 19.5 onto that. You're welcome to upload your your examples and then your practice problems as well. Okay, so let's go ahead and I'm going to pull this up here. So I'm going to share my screen. So let's share. So let's start with our folder, okay? This is our folder for the class. Let me make sure this is working. Okay, so this is our folder for the class, okay? In our folder for the class, we have some books in here. So the first one that is important is the physics one, right? That's the college, a copy of the college physics. Then you have volume 1, volume 2, and volume 3 for the calculus. Volume 1 is the one for calculus 1, and then there's one for calculus 2, and then one for calculus 3. You don't have to worry about these two for now, but they're there in case you are just going very fast through calculus. So we're not using this book now. We're going to use it after we finish the one you're in, the one you're working on right now. This is the one we're going to start using. My goal is that by December, we're going to be focused on this book because it has practice problems for us as well in AP calculus, right? So this book is going to be a very good tool for teaching you how to practice for the AP exam. Okay, let me go back now to physics. Before I do that, I do have this document called Veritas 2024-2025. And in this document, it basically has all the dates for the year, and I'm going to fill it in with information. So for example, we should turn in everything related to 2.1 by Monday and finish chapter 19, by Monday. And so we're going to start filling in, okay, 20.2. Here we're going to have chapter 2.2. So we're going to start filling in this information, but always keep moving forward though, because what you don't want to happen is you don't want to fall behind. If let's say something happens in your schedule and you can't keep up with your work in math and physics, you want to get ahead. So please do that. Keep that in mind. So I'll fill this out more, but it's a guide. I'll also make a focus. I'll put focus points for what we're going to discuss. So for like this week, we're going to discuss something specific in math and something specific in physics, right? We're still working on our kinematic equations of motion, Newton's laws of motion. That's what's going on this week, right? Okay, so I'll send that information out for this week. And then even over Thanksgiving, I would encourage you to keep reading. So here's my recommendation. Read the chapter, read and write the equations, right? Write the equations and then do the practice problems, right? Those are some things to keep in mind. Okay, so let me stop sharing. let's now go to the textbook. I want to show you something from the textbook. So now I'm going to share with the textbook for physics specifically. Okay, so we have, let's see. Okay, physics. So this is the physics textbook. So we have college physics for AP courses. Let's go down to the table of contents. Rice University, by the way, is one of the main groups that helped with putting this together. If you're interested in applying to Rice for school, let me know. I live near Rice and I've been able to connect with some of their professors. Very nice institution. Okay, so here's the situation here. We've talked about chapter 1. You've had an opportunity to do chapter 1. Let me go back up. Sorry, I clicked on it by mistake. So there's about 34 chapters, but please note that this is multiple physics courses in one. This is not just one AP physics. There's multiple here. So we've done chapter 1. We've talked about the nature of science and physics. We're working on kinematics, but notice that chapter 2 and chapter 3 are about kinematics, right? So you do 2.1, you read the chapter, you do the practice problems, and then you move to 2.2. You read the chapter, you do the practice problems. You do 2.3, you read the chapter, you do the practice problems. Every day, we're going to keep reading. You read, write the definitions, write the formulas in your notebook, and then do the practice problems. Ideally, what I would love to see over time is your work after you've read the chapter. Like, what did you note from what you read? And I can give you feedback on how to improve on taking notes. So we're going to be implementing that more and more as we go in through to the other chapters. So read the chapter on 2.1. What are the formulas that 2.1 talked about? What are the definitions that 2.1 talked about? Let me actually click on it. Okay, here's 2.1, position, right? Okay, so make sure you can define what position is. If it's a bold term, we should be able to define it. Okay, so we have a formula here. Okay, this is pretty straightforward. Change in X is final minus initial. Again, reading the chapter is going to be good. You're going to see the examples. Very good. There are some things that depend on the student. So not everybody will write every single thing in the chapter the same way, but there are some things we should see. We should see those definitions. Sometimes we should see those examples. Then you see 2.2. You read the chapter. What is the definition of a vector? Any quantity with both magnitude and direction. Okay, and then check your understanding. Do you understand this? You know, you can even read their question here and see how close your answer is compared to their answer. And then 2.3, you read the chapter, write down the definition. Write down any formulas, like key formulas, and then do the practice problem for 2.3, which is at the end of the chapter. Then you have 2.4, acceleration. And now I know we should be done with chapter 2. We're catching up in trying to get like everybody on the same page. So please, let's finish chapter 2 as soon as possible. And chapter 3, we need those ones out of the way. We've already discussed a lot of the types of problems, and some of the formulas are very straightforward. So we should be able to finish them pretty quick here. It's going to take discipline and commitment, but you can do it. So do your best to read through chapter 2 and 3 as soon as possible. Starting in chapter 4, I'm going to standardize the chapters so that everybody is on chapter 4.1. Everybody's turning in work for that at a specific due date. Okay, so that's chapter 2, material, acceleration and time, velocity. Those are the types of information that you see in chapter 2. Okay, now we're going to go back to the table of contents. Okay, so let me go back to the table of contents. Here's our goal. Our goal is to finish about one section at least a day, potentially even 2 sometimes, because again, our goal is 1 hour. 1 hour of solid work. Okay, so that's chapter 2, chapter 3, moving more into Newton's laws of motion in chapter 4, and then chapter 5, which is on friction, drag forces, and elasticity. We could finish some of that in 1 week when we get to chapter 5. Then we're going to move to the circular motion and gravitation. Newton's law, universal law of gravitation. It's very important here. Kepler's laws. Work, energy, and energy resources. That's a longer chapter, chapter 7. So again, just keep moving to the next section. Keep moving to the next section as you work. Now, we are going to do end of chapter quizzes, and then we'll do exams, which I'll tell you the due dates of those. The best way to prepare for the quizzes is to do the odd problems that are assigned from each of the sections. These Test prep for AP courses. That's a very good way to practice the AP course questions. So you have chapter 8, chapter 9, chapter 10. It starts getting intense in chapter 11 as well, 12. We're going to go as far as we can, and I will send you the syllabus later. But the further you can get in this, the better for you when it comes to the exams and just your understanding of physics. Okay, let's keep going down. Let's see how far it gets. Notice that there are some chapters that are not on the AP exam, but it's just good to know what those concepts are in physics. At the end of the book, which this is like modern physics of a you get into quantum physics, modern physics, Einstein's theory. That is getting into chapter 28, 29. 30 is actually chemistry and physics combined. Atomic theory is discussed in both. 30, and then you have 31, 32, 33, and 34. So if you get as far as these chapters, you're going to have a very solid base in physics. Now, you would notice that in our class folder, I actually include a chemistry textbook for you as a reference. If you need to look at a chemistry textbook, you have that available to you as well. So students, you have all that it takes. Before I say more, let me show you the calculus here. I don't know if it's showing up on your screen, but there's a calculus textbook here, which is the one we're going to use after. One of the authors of this text has been teaching at MIT for like 40 years. So that's very cool. If you go down to the table of contents, you'll notice that the first chapter is a review, which we've already done. So we're not going to do the first chapter. The second chapter is pretty much review, same as the third chapter. But we're going to just cover these briefly and look at how they connect to the AP exam. And then it goes into integration. So there's 6 chapters. We'll go through these pretty quick, and then you're done with Calculus 1 material, and then you're just going to be doing practice problems. That's all we're going to be doing. Practice problems for the AP exam and preparing for, if you want to do the second calculus course, we can do that as well. Okay, so let me stop sharing. So here's the deal, students. You have the tools to be successful in math and science. I really want to encourage you guys to apply yourselves to excellence in your studies. Make sure that you're dedicating 1 hour at least to math and 1 hour at least to science. Even if possible, even on some Saturdays, I would encourage you to do that. Be very careful with wasting time on technology and just scrolling the internet, right? Make sure that you use your time wisely. Some of you are going to be graduating soon. I want you to be able to apply to top universities if you want. I want you to be able to get scholarships if that's what you want to get. So please make the time every day and be able to show the work that you did that day. Every day you come to class, be ready to take a quiz that goes over the section that you should have reviewed before coming to class. So for example, on Tuesday in math, you should be comfortable with all the concepts in chapter 19. If you're not comfortable on a concept, email me please at amosthemathguy@gmail.com, and I can give you strategies or videos to watch. But please email me before class if you are struggling with any concept in math or physics. On Thursday, when we have physics, you should be comfortable with doing problems with the equations of motion. So we'll start with the classwork problem, and then we'll do the solutions to that problem, and then I'll grade that, and that'll go into your grade book. And then you will learn the lesson for the day, and then you have time to practice. But please do your best to make the most of the time. You guys are in a very unique situation because you're learning calculus and physics at the same time, and you have access to other resources in the class folder. Let's do a great job working hard, okay? Yeah. Encourage one another as well. So, okay, so let me know if you have any questions. We will talk soon. Take care and have a blessed day.